Hi everyone, this is Dr. K.G. Shanti, Professor, ECE, R.M.K. College of Engineering and Technology. In this video presentation, we are going to see about convolution sum of infinite sequences. Right, now convolution sum is given by the formula y of n is equal to summation of k is equal to minus infinity to infinity x of k into h of n minus k, which can be represented as x of n star h of n, where this star is going to represent the convolution operation. Now let us look into the convolution sum for an infinite sequence with an example. See here, x of n is equal to a power n into u of n and h of n is equal to b power n into u of n. Right, now what is u of n? You all know what is u of n. U of n is nothing but a step signal, right? How does a step signal look like? Right, see here. A step signal is going to be 1 from 0 to infinity, right? Yes or not? From 0 to infinity, it is going to be 1. That is for n greater than or equal to 0, u of n is going to be equal to 1. So that is why you call this sequence as an infinite sequence, right? In the same way, h of n is equal to b power n into u of n. Similarly, it is getting multiplied by u of n, which means that u of n is equal to 1 for n greater than or equal to 0, right? So we are going to find out the convolution of such sequences, right? Now how will we proceed on with finding out the convolution sum of such sequences? Right, now this is the formula for finding the convolution sum, right? Next, right, and where x of k and h of k are written. Now I'm going to replace x of k by a power k into u of k, and you have h of n minus k, which means that h of n is b power n into u of n. So what I do is b power n minus k into u of n minus k. You apply the same delay here for the input h of n. Okay, right. Now I plot x of k. What is x of k? X of k is nothing but a power k into u of k, right? And the condition here is a is less than 1. So if I plot it, I get a curve of this sort, right? And since it's multiplied by u of k, you all know u of k is equal to 1 for k greater than or equal to 0, right? So it will be a causal sequence like this. And if a is lesser than 1, we will get the sequence like this. Okay, right. In the same way, when I plot h of k, I am going to even get the sequence of h of k like this. Now what I am going to do is I am going to plot h of n minus k. Right, now when I plot h of n minus k, what you do is, how do you obtain at this diagram is, you first fold h of k. When I fold h of k, it will be h of minus k, and h of n minus k is I give a shifting by n, right? Now what I have to do is I have to look into these two sequences. See here, the formula is x of k into h of n minus k. So I have to look into x of k and h of n minus k. So where is the overlap in, when I multiply this diagram with this diagram, where is the overlap? So that is the main condition what we have in determining in a infinite sequence, right? So the overlap here is going to be from 0 to n. See here, it is extending from 0 to infinity. Here the sequence extends from 0 to n, which means that the overlap is going to be from 0 to n. So what will be your k value becoming now? K is going to become equal to 0 to n. See here, that is what is shown here. So what will happen to your formula? Y of n is equal to k is equal to 0 to n a k into b of n minus k. U of k is 1 and u of n minus k is also 1. So a per k into b of n minus k. Now what I do is, since the the summation is based on k, b power n minus k can be split as b power n into b power minus k, and I take that b power n as constant outside. So I have summation of k is equal to 0 to n a k into b power minus k, right? And what I do is this b power minus k can be written as 1 by b power k, right? Now b power n into summation of k is equal to 0 to n. a by b the whole power k, right? Now what I do is I'll use this formula. What is the formula? Summation of n is equal to 0 to n, x of n is nothing but 1 minus x the whole power n plus 1 by 1 minus x, right? So that is the formula what we are going to make use of. Now the sequence is very similar to this. Summation of k is equal to 0 to n. Instead of capital N, I have a small n, and x of n, where x is a by b now, right? So I'm going to apply this formula. When I apply this formula, what will I have? Y of n is equal to b power n. I have 1 minus x the whole power n plus 1. So 1 minus a by b the whole power n plus 1 divided by 1 minus a by b. Okay. Right, now this is equal to b power n 1 minus, I am splitting a power n plus 1 by b power n plus 1, and what I do is I take an LCM also of both numerator and denominator. When I take an LCM of both numerator and denominator, it is going to be b of n plus 1 minus a of n plus 1 by b power n plus 1. Okay. And when I take the denominator here, what will I have? LCM b minus a by b. So when I write it, it will be b by b minus a. Right. Now look into the next step. So you have, this is the continuation from the previous page. So you have b power n. So b power n plus 1 minus a power n plus 1 by b power n plus 1 into b by b minus a. Right. Now what I do is this b power n plus 1 can be written as b into b power n. Am I right? Right. Now what are the cancellations I can do? B power n and b power n gets cancelled. This b and this b gets cancelled. So what I have? B power n plus 1 minus a power n plus 1 by b minus a. So the answer is y of n is nothing but b power n plus 1 minus a power n plus 1 by b minus a into u of n. So this is how we have to do problems of problem for convolution sum in the case of infinite sequences. Okay, right. Now I shall even show you one another problem, right? See here, the question is find the convolution sum of x of n is equal to r of n and h of n is equal to u of n. Right, now x of n is equal to r of n is a ramp sequence. You all know ramp sequence is what is ramp sequence? Right, now a ramp sequence is going to be, the diagram is going to be like this. It is going to be that is, you will say r of n is equal to n for n greater than or equal to what? 0 to infinity. So for 1 it will be 1, for 2 it will be 2, for 3 it will be 3, so on. So that is going to be your ramp sequence, right? So this is an infinite sequence. And similarly, what is h of n? H of n is also an infinite sequence, right? Since it's u of n, it is going to be 1 for n greater than or equal to 0 and it tends to infinity, right? Now see here, this is the formula for your convolution sum where x of k is equal to r of k and h of k is equal to u of k. Now what I do is, given h of k, I find out h of n minus k, right? And I told you how to find out h of n minus k. You do a folding of h of k and then shift right by n places, right? So I get the sequence like this. Now what I have to do, I have to multiply x of k and h of n minus k, or I find out the overlap. Where will be the overlap? This sequence extends from 0 to infinity, whereas this sequence, it extends from minus infinity to n. So where is the overlap? Overlap is going to be on the right hand side from 0 to n, right? So what happens? Overlapping is going to be from 0 to n, right? And what happens to your formula? Y of n is equal to k is equal to 0 to n, r of k into h of n minus k is u of n minus k, right? Now what happens? R of k is equal to k into u of k, which is equal to k, and u of n minus 1 is equal to 1, right? I substitute that in the formula, right? So what will happen? See here, summation of k is equal to 0 to n, because we found out the range, the overlap is from 0 to n. So 0 to n, it is k, right? So k is equal to 0 to n, k is going to be, what is it? We are going to use the formula, it is going to be n into n plus 1 by 2. Okay, so that is going to be your answer. So what I do, y of n is going to be equal to n square by 2 into u of n plus n by 2 into u of n. Is that clear? Right, now this is how one another problem I have shown. Right, now I shall even show you one another example. Determine the convolution of x of n as cos n pi into u of n and 1 by 2 the whole power n into u of n. Even this is an infinite sequence, right? Now cos n pi, you all know what is cos n pi, minus 1 the whole power n into u of n, and what is h of n given, 1 by 2 the whole power n into u of n, right? Now both are causal sequences, right? And when I multiply, you will get the overlap range as 0 to n, right? As we have seen in the previous two problems. So what is your overlap? K is equal to 0 to n, x of k into h of n minus k, right? And what is x of k? It is minus 1 the whole power k into u of k. And what is h of n minus k? It is 1 by 2 into n minus k into u of n minus k. So all that is going to be 1. So what I do? I just see here, k is equal to n is equal to 0 to n, x of k into h of n minus k. I have redone it. So minus 1 the whole power k into 1 by 2 the whole power n minus k. So this is going to be, I'm going to split this and write. So what I'll have, 1 by 2 the whole power n into 1 by 2 the whole power minus k, right? Now this will be constant with respect to k. So I'm going to take that out, right? Now in the next step I'll be taking it out. Right, so see here I have taken 1 by 2 the whole power n out, and summation of k is equal to 0 to infinity. So it is going to be minus 2 the whole power k. I apply the formula. So what it will be, 1 minus x the whole power n plus 1. Here the x is going to be minus 2 divided by 1 minus 6, right? So I get this answer, right? So what I do? So I completed. So 1 by 2 the whole power n, 1 minus 2 the whole power n into minus 2 divided by what will have, minus and minus will become plus. So it is going to be 3 here. So 1 by 3 into 1 by 2 the whole power n minus, yeah, here what I do is I take this minus is here, minus and minus becomes plus. So this 2 here, 1 by 2 the whole power n and minus 2 the whole power n. Right? This minus and minus becomes plus. So what's your final answer? Y of n is equal to 1 by 3 into 1 by 2 the whole power n plus 2 into minus 1 the whole power n into u of n. Right? Thank you all students.